What's going on, YouTube? Today is January 24th, 2014. It's about 5 o'clock in the morning here in Virginia Tech. I had a quick inspiration to do a video on dark matter and dark energy. So back in 1998, astrophysicists figured out that the universe isn't collapsing, it's actually expanding. And we know that galaxies farther away from us are expanding at a faster rate than the ones that are closer to us. Okay? Now, dark energy apparently makes up 68% of the universe. Dark matter makes up about 27%. And everything else, you guys, the visible matter, the visible universe, atoms, make up 5%. Okay? The elements, the periodic table that you know, that you studied in chemistry, all of that, everything, every single one, stars, planets, moons, asteroids, you, me, we're all made up about 5% of what's around us, what's everywhere. Okay? Now, where is this dark energy? Where is this dark matter? Well, it's in space. The parts that's in between planets, in between suns. The dark energy is, as the planets and stars move away from each other, the space in between is the dark energy that's pushing it. It's that force that's pushing it. Well, why do we call it dark? We call it dark because it behaves differently than the normal atoms, the normal visible matter that we have. It doesn't reflect light. It doesn't emit light. It doesn't interact with electromagnetic radiation like all the other matter does. But we know it's there because we see its influence. It's constantly moving galaxies away from one another. Now, to give you a concept of how much dark matter and dark energy there is, I want you to visualize our sun. Take our sun. You know, it's the only star that we have, and it is 100 times bigger than Earth, but it's 1,000,000 times more massive as far as, not massive, as far as volume is concerned. You can take 1,000,000 Earths and put them inside of our sun. If you opened it up and just put 1,000,000 Earths in, it would fill up all the way. It's incredibly enormous. Now take the sun, shrink it down to the size of a grapefruit, okay? Then you picture our solar system with our 9 planets, Pluto. It would be about half a mile away from that grapefruit, but it would be the size of like a speck, you know what I mean? It's tiny compared to the sun. It would be like a pinhead compared to the sun, compared to that grapefruit. It's all ratio. Now, the nearest sun, the nearest star, if you were to take our sun and shrink it to a grapefruit, if you had it in Virginia Tech, the nearest star would be in Los Angeles, California. Do you have any idea how far away that is in space? If you are a sun, the nearest thing is, I don't even know how long, how many light years away it would be. It's not 3,000 miles away, because guys, it's ratio, so it's reversed. It's the other way. It's not, 3,000 miles, not from Virginia Tech to LA. No, it's our sun to the nearest galaxy, I think, is the Andromeda galaxy, which is, I forget, like 4.3 light years away. I'm not sure, to be honest with you, but it's far. So all that space is dark matter, has dark energy, and it's pushing everything away from it. It's like, it's invisible to us, though. We call it dark, and I think it's so interesting. This stuff is cutting edge. It's brand new stuff. And all this information, guys, came from NASA's website and from Virginia Tech, the astronomy courses that I'm taking. So you can go look on NASA's website if you want. Confirm all this for yourself. Physics. Space. So interesting to me. Alright, take it easy, guys. I'm sorry it's not a a bodybuilding video. It's not about muscles, but I'm just really interested in this stuff, and I want you guys to get an interest as well, because there's so much more than just us in this universe. So much more. Alright, take it easy. This is the Lazy Lion. Peace.